Okay, let's take a look at a couple of examples where we see rational exponents. The first, 9 to the 1/2. Remember, if I write anything to the 1 over n power, that's the same thing as the nth root of that value. So this would be the same thing as the second root or square root of 9. And of course, that's the thing you can multiply by itself to get 9 or 3. If, on the other hand, we had 8 to the 2/3, here we've actually got a couple things going on. And one way you can think about this is to rewrite this as 8 to the 1/3 squared. Okay, notice, of course, power to a power here, you would end up multiplying those two exponents together to get 2/3, so this is legitimate. 8 to the 1/3 we now recognize as the cube root of 8, similar to how this was the square root of 9 above. So we have the cube root of 8 squared, bringing that 2 along. The cube root of 8, of course, what number can you multiply by itself and then again by itself to get 8? That would be 2. And so we have 2 squared here, which of course is 4. Notice, it is more efficient to deal with the 1 over 3 here as an exponent before dealing with the 2 as an exponent. Our numbers are smaller, right? I mean, we could certainly work it the other way as well. We could say this is 8 squared to the 1/3. Here again, the product is 2/3. That agrees with this. 8 squared, of course, is 64. And then, of course, you're raising that to the 1/3. And this is the cube root of 64. But look how much more difficult this is because the numbers are larger, right? You may know that the cube root of 64 is 4, you may not. But certainly everybody should know 2 squared is equal to 4. So when you have a choice here, deal with this taking of a root first if you can, if it's convenient. Okay? All right, how about a third example here? How about negative 8? In parentheses now to the 1/3 power. This, of course, is, again, taking a cube root. That's what raising to the 1/3 power will do for us. The wrinkle is that this is a negative value. Of course, we could rewrite it as the cube root of negative 8 like this. Certainly 2 times 2 times 2 gives us the 8. So we know a 2 is going to be involved. And in order to make it negative, recall negative 1 cubed is negative 1. So if I just throw a negative on there, we're good to go. Likewise, if I had negative 27 to the 4/3, here again, there's a raising to the 4th power involved here. There's also taking a cube root involved here because that 3 is on the bottom of that fraction. If you wanted to write it out explicitly, you could say, well, hey, that's negative 27 to the 1/3. And then all of that to the 4th power. This interior part here, negative 27 to the 1/3 power, that's the cube root of negative 27, which of course is negative 3, by a logic similar to the previous example. We still have to raise that to the 4th power. Notice we're raising the negative part as well to the 4th power, which means, since this is an even number, you have an even number of negatives multiplied together, so that's going to be turned positive. And we're left with simply 3 to the 4th, or 81, if you multiply that out. Do notice the efficiency I mentioned before in terms of taking roots before raising to powers. If we look at this case down here, if I had written this instead as negative 27 to the 4th, and then all that to the 1/3, I've got to raise 27 to the 4th power, right? Which I probably can't do in my head. I do know it's positive. I might need to appeal to a calculator, though, to discover that it's 531,441. And then, of course, I'm raising that to the 1/3 power, or taking a cube root. And again, I'd probably have to appeal to a calculator to realize that was 81. Don't go this route. Okay, this requires much more work than you need to do. Okay, deal with taking a root, reducing the size of that number before raising it to a power here. Let's finish up with one more example. Negative 2 to the 3/4. Okay, here again, I'm going to split this into two pieces. I've got a negative 2. Let's deal with the radical first, the root first. That's negative 2 to the 1/4 power, and then all of that to the third. So inside here we have negative 2 to the 1/4 power. That's the fourth root of negative 2 being raised to the third power. But that's a problem, isn't it? I'm looking for a number that I can multiply by itself 4 times and get a negative value. There's no real value that makes that work. Okay, so this is simply undefined. Okay, this is not a real number. Okay, and those are some examples of using rational exponents.